One big question that comes up is how do these chimneys perform in the longer term? This is the topic that we will be hearing about today. Our speaker is Marcus Rost of Constructure, and Marcus will be speaking about two chimneys, new chimney design chimneys, where Constructure has monitored their long-term performance. Marcus, if you are ready, we would like to turn it over to you, and I would like to ask you to take over the screen.
Good afternoon. Yes, good afternoon, Mr. De Krij, to India. My name is Marcus Rost. Today, I'd like to show to you our experience with the long-term performance of the new chimney design. The presentation will be is structured as follows. At first, Albert De Krij gives a short introduction, then he will hand over the presentation to me, and I will introduce you in some structural characteristics of the new chimney design and going over to our inspection procedure on the two new chimney design in Poland. We assessed their condition after several years of operation. On one hand, a wet stack located in Padnov and a hot stack chimney in Siekierki in Poland. At the end of my presentation, I close with a short conclusion, and after the presentation, we will have sufficient time to discuss the questions. The new chimney design, abbreviated with NCD, I would like to describe in comparison to other chimney types. Maybe the most common one from the former time is for us cold type 1, reinforced concrete chimney with a brick flue gas duct, a single brick flue gas duct supported on platforms and having a ventilated space between the flue gas duct and the reinforced concrete windshield. The duct barrels itself are supported on steel or reinforced concrete platforms on different levels. Second option for a single flue chimney is to work with a steel or fiber reinforced plastic lining, usually hanging at the very top of the chimney, supported at a steel platform, and with a compensator at the bottom of the cylindrical part shortly above the duct area. The corrosion protection for the steel part can on one hand be provided with some kind of coating, when usually an outside insulation is in addition required, or with the Penguard block lining system on the inside, which includes both the corrosion protection and the thermal insulation. And last but not least, we have the new chimney design, which does not have real flue gas duct inside. The windshield is taking over both roles, the structural part of the chimney and also the flue gas duct. The insulation and corrosion protection is provided with Penguard block lining system without having a ventilated space between the lining and the windshield. Results in slender chimney structures. Typical details for the Penguard block lining systems are the single wall. You can see here clearly the concrete windshield with the jacking rod channel here. The chimney will be slided by slip forming, and on the inside is the Penguard block lining system. At the very top, you can see the inside surface of the chimney with the upper part, which is some kind of condensate drain and a protection of the concrete part of at the very top, and collecting the drops maybe occurring here at the very top of the chimney. And the bottom part with the duct entrance here, the wings which guide the flue gas stream into the right direction, and there's a hopper here, there's a floor at the very bottom. You can see here clearly the Penguard block lining system not also is put into the windshield, but also the duct area is cladded with this product. The next chapter, what we did, or which kind we have been supported during our inspection, was we assessed the windshield from the outside, especially regarding cracking, but also checked the overall condition. An inside inspection has been done. We did it from the duct area and the top area, and we have been supported by photographs of a team which also did the inside inspection in the regular area. And since one chimney was in operation, I gave here example, an old example of a brickwork chimney. We did thermal imaging, which is very suitable for inspection of new chimney designs, because if there occurs a crack, for example, in the chimney where cool ambient air will probably sucked in, you can see it here clearly on this example on the light color cracks here. And if there would be, for example, a continuous wear of the thermal insulation on the inside, you can see it with hotter areas on the surface. And since the new chimney design do not have a ventilated space, you can detect any all deficiencies quite directly via thermal imaging. In comparison to the other chimney types, where the chimney has to be taken out of operation probably to do an internal inspection. Here you can see the first chimney we inspected. Chimney is located in Pardnów in Poland. It has been erected in 2006 and has a height of 150 meter. The height of 150 meter allowed the operator to build it in a cylindrical shape with an outside diameter of about 9 meter. The fuel of the power plant is lignite, and as you can see on the picture on the right hand, it is a wet stack with water saturated flue gases and a flue gas temperature of about 65 degrees centigrade. And here you can see the first pictures after more than 10 years of operation from the very top. We did a lot of photographs. Here is a short selection. What you can see is we have intact internal surface without cracks and with minor caking at the stainless steel parts, but nearly nothing, no dust on the inside of the lining surface. We have no corrosion on the steel parts, and it's after 10 years of operation quite clean at the very top and without any visual damages. We got photographs from the inside surface, and here you can see that the pen guard, the individual blocks are intact without crack. You can see the adhesive at the edges of each blocks, which is still there, and it was flexible. You can see a detail of a block surface with the pores, and you can see there we have no dust deposits. And if you compare it with the joint of the left hand, you can easily see that there's no wear off, no abrasion of the internal surface. What has been proven by taking out one block to check the remaining thickness of the pen guard block lining system after about more than 10 years of operation. And it is still 2-inch thickness there. On the next page, you can see the thermal imaging of the duct area. And what you can clearly see is the area when the inside surface is subject to hot flue gases. Because you can see here below the hopper, everything is cold. And above you have a uniform temperature distribution on the surface, and we detected no suspicious areas where the pen guard block lining failed. Here in the compensator area, you can see that there is a lack of insulation here, and there the temperatures are a little bit higher. But this is not an issue of the pen guard system, but of the compensator. Okay, and last but not least, we did an inspection on the windshield. Since the windshield is exposed to ambient temperature on the outside and flue gas temperature on the inside, it is important that the thermal insulation of the Penguard block lining system is sufficient and the reinforcement of the shell is okay. So, and here you can measure the function of the windshield by the width of the cracks. And on the chimney, we found only very small crack width of about 0.1 millimeter and uniform distribution of these cracks on the circumference. So the reinforcement corresponds with constraints caused by the temperature difference from the inside to the outside and reduced by the thermal insulation of the Penguard block lining system. So we detected no deficiencies on the windshield caused by cracking. The second chimney we have inspected is located in Sierkierki. Sierkierki is also next to Warsaw in Poland. The erection date was about 2009. It's a power plant chimney with a height of about 170 meters. The increased height required conical bottom part of the chimney with an outside diameter of about 10 meters. And the fuel of the power plant is hard coal and biomass. It's a hot stack with a waste gas temperature of about 140 degrees centigrade. As shown, well describes the findings on the chimney analogous to the first one, starting with the very top. You can see here as well an inside surface without caking and also without cracks. Yes, in a quite good condition. The thermal imaging we did of the entire chimney, but focused on the duct area, revealed no deficiencies of the inside block lining system. And as I discussed before and explained before, the hot spots on the chimney are caused by the weaker insulation of the compensator here in the duct area of the chimney. So we had found a uniform temperature distribution with no indication for damaged inside surfaces. The conclusion for both chimneys can be described with three headlines. We detected on both examples flawless windshield surfaces with cracks with very limited width of about 0.1 millimeter, which is fully acceptable and quite typical for this new chimney design and in accordance within all requirements of the individual regulations. This is the result of the flawless lining surface. We detected a Penguard block lining system surface without damages, without caking on it, and with tight joints and flexible adhesive. Yes, the adhesive is the second component of the Penguard block lining system, which works together quite reliably with the blocks to hold them together in an elastic way because it is necessary because of the thermal actions, the thermal load on the block lining system, which requires a certain expansion. And it was for us quite easy to assess those new chimney designs with the help of the thermal imaging, which revealed every potential failure of this block lining system. And with an additional help of the inspection of the duct area and the top area, which was very easy to provide for the regular ladders and staircases. So at the end of the day, internal inspection of the lining is not really necessary.